All right, so we're going to be looking at parallel lines and, thank you, parallel lines and transversals. So as we talked about a few minutes ago, this is a plane. It's a flat surface. Um, Plane is an undefined term, but we agree that we can have, if we have three coplanar points, 3 points on the same plane, define the plane. What I'm going to do is I'm going to draw two parallel lines on that plane. How do I ensure that the lines are parallel? I ensure that they're parallel by making the perpendicular distance. See the distance from there to there? Right here, that distance from there to there is the same distance from there to there. That makes them parallel. And then I'm going to draw transversal. So these line L and line M are parallel. I'm going to make line T the transversal. So let's write that in our notes. Line L and line M are parallel. Well, if that is true, then we say that L, see how it's in cursive? L is parallel to M. That's our notation. And line T is a transversal. Well, what does it mean that it's a transversal? Just by looking at it, just like we did on the first week's assignments, just by looking at it, if line T is the transversal, what do you think transversal might mean? Go and pause for a few seconds and think about that. What do you all think? Transversal. The word trans means to cross. Trans means to cross. And notice what happens at this point and this point. They cross at two distinct points, right? So see how line T crosses at one point there and one point there? That makes line T the transversal. So now let's label the interior angles. Angle 1, angle 2, angle 3, and angle 4 are going to be interior angles. So I'm going to say 1, 2, 3, 4. What makes them interior? This is the way I like to think about it. If line L and line M were walls, and if those walls could move, see those two walls? If those walls could move towards each other, could I possibly squeeze angles 1, 2, 3, and 4? Could I squash them? See how I could squash them? It's like Indiana Jones movies, the walls moving towards each other. And I'm going to squash those angles. That makes them interior. But angles 5, 6, 7, and 8 are not interior angles. Angles 5, 6, 7, and angle 8 are exterior. They're on the outside of those walls. See, if I try to move these walls away from each other, I'm sorry, if I move these walls towards each other, 5 and 6 are saved. They didn't get squashed. They're outside the walls. 7 and 8 are saved. They're outside the walls. They will not get squashed in the process of these two walls moving towards each other. So here, angles 5, 6, 7, and 8 are called exterior angles. I'll pause there for a few seconds. There's a lot more to this, but this is the beginning of that vocabulary that we're going to be building. Now, let's concentrate on the transversal. See this transversal right here, T, divides numbers on the left and numbers on the right. So we can say that angle 5, angle 1, angle 3, and angle 7 are on the same side. I'll pause there for questions. So now I'm going to combine these two ideas. Which angles are both same side and same side and interior? Well, for it to be same side interior, it's got to be on both my lists. Is 5 on both of them? 5 is not on both. So although they're same side, they're not interior. It's an exterior angle. Angle 1, it's on both of them because angle 1 is on the same side as angle 3. They're both on the same side and they're both interior. You see how angle 1 is on the same side as angle 3 and they're both interior? 5 and 7 are on the same side, but they're exterior. So here I can say same side, exterior, are angles 5 and angle 7. They're both on the left-hand side, they're both on the same side, and they're both outside. They're called same side exterior angles. And somebody's wondering, well, sir, I could argue the point that 6 and 8 are on the same side, and 6 and 8 are also exterior, and I would have to do nothing else but agree with you and say, yes, sir, you're right. Or yes, ma'am, you're right. And then you could say, well, sir, 2 and 4 are interior and they're also same side. And I would say, I beg for your forgiveness. You are right. I'll pause there for questions. Okay. All right. So that is the foundation. We're going to study it more, but that's the foundation for what we're doing in these problems. Okay. Uh, there's more to it, but we got to be able to start defining them first. There's another set of vocabulary terms that we've got to define. Well, what if they're not on the same side? For example, angle 1 and angle 8 are not on the same side. See this transversal? The 1 is on the left and the 8 is on the right. So if the angles are not on the same side, for example, IE means example. For example, angle 5 and angle 8. Or we could say angle 3 and angle 4. Do you see how 3 and 4 are on opposite sides? They're not on the same side. Angle 5 and angle 8 are not on the same side. They're on opposite sides. Well, that is what we call alternating angles. Why? Because they alternate sides. They switch sides. They say, you be on the left, I'll be on the right. So they're alternating. So some examples of alternating interior. We'll continue with that tomorrow. I'll be posting this today as soon as I finish editing. As soon as I finish editing it. Okay. If